Okay, here's an example of a problem where we're going to do it by making up numbers, but you're going to find that you're going to have to do what I call making up a variety of numbers. Because the first one that you pick isn't going to be enough to really kind of give you a complete idea of what's going on. Okay, so he says here, if x is a negative number, which statement of the following must be true? So generally in these kind of problems, I try to make the Roman numeral statement false. And if I do sufficient enough examples where I cannot do that, then I would say that that statement would always have to be true. Is that me proving it? No. But again, in an SAT problem, you really don't have to necessarily prove it. You just have to have enough information so that you convince yourself that you've done the right thing. So normally I can do that. I probably wouldn't need more than like 3 examples, even in the hardest ones of these kind, but usually with 1 or 2, it should be enough. So let's take a look at this one. So I'm going to go in and I'm going to start by picking x to be -1. And when I do that, I find that the first statement is -1 is less than 0, so that's going to be true. -1 cubed minus 25 is -26. That's not less than, or that's not greater than 0, that's less than 0. So statement 2 is out. And if I square -1, I get 1. 1 plus 1 is 2. 2 is definitely greater than 0. So it turns out in my first example, statements 1 and 3 did work, statement 2 did not. So I go down here now, anything that has statement 2 in it has to be crossed out. So C is out, D is out, E is out. Maybe it would work in a different example, but the question says it must be true. So I found a counter example, so statement 2 cannot must be true. So we crossed them out. So now it's either that none of them must be true or statement 3 only must be true. So this time I'll go in, I'll try x equals, let's say -4. Because I'm just going to pick a bigger negative integer because that seems kind of easy. Okay, so here I have -12 plus 2 is -10, so that worked again. And -4 quantity squared is 16, plus 1 is 17. That's again bigger than 0. So that didn't really help me eliminate anything. So again, that means that maybe they both work, which isn't an option, so that probably can't be true. Or maybe I need to do it again. So what you need to remember is that it didn't say that it had to be an integer, it just said it had to be a number. But when I talk about making enough of a variety, don't just think about doing integers, you want to think about decimals as well. So for example, say that if I pick x to be -1/2. Okay, if I go in now, I'm going to have 3 times -1/2 is -1.5 plus 2 is bigger than 0, it's 0.5. So even though in my first 2 examples the statement will work out, in my third example it doesn't work out. So that crosses out, but in this case -0.5 squared is going to be positive 0.25 plus 1 still up as a positive number. So probably by this point you're convinced that statement 3 is always going to work, and you could prove that because clearly if you square any number, the lowest possible you could get is 0, and 0 plus 1 has to be a positive. But for those kids who struggle with doing sort of like internal proving it, certainly by the time you've done 3 examples, and if you've done enough of a variety of examples, you can be very confident that that particular statement, if it's still working, will work all the time. So it turns out here that the answer is going to be B. Only statement 3 of the 3 listed work all the time.